This is problem 4-29 on page 136. Determine the moment of each force about the bolt located at A. Take FB to be 40 pounds and FC to be 50 pounds. Well, what they've got here is a breaker bar attached to a wrench. They're trying to turn a nut that is at what they call it point A down here. And there's in the picture is shown two hands apply, well, two gloved hands applying force, one generally in this direction, one generally in that direction. More particularly, if we drop perpendicular lines, the angle for force B, which is 40 pounds, that angle is 25 degrees. And the angle of FC, which is 50 pounds, is 30 degrees. These 2 points are separated by a distance of 3/4 of a foot. And point B is separated from point A by a distance of 2.5 feet. Now at this point, there's also a 20-degree angle with horizontal. So let's set up our typical XY coordinate system and compute the moment of each of these forces about A. So summing moments for B about A, taking counterclockwise as positive, I look at it and I think, you know, I made a mistake in the way I set up this coordinate system. I made my life difficult because now I'm going to have a vertical and horizontal moment arm. Why don't I take my coordinate system and simply rotate it so that it is parallel, well, at least the x-axis, is parallel to the arm of the wrench. And now, all I really need to do is take the component of FB in the y direction, multiply it by the x distance of 2.5, and that would be the moment of FB about A. So that's what I did. FB, total magnitude, I want this piece of it in the y direction. So let's see, that's touching the angle, so that's the cosine side, so cosine of 25 degrees, multiplied by the moment arm of 2.5 feet. Now, of course, FB is 40 pounds, so all we have to do is hit buttons on the calculator, and we'll find this is 90.63 foot-pounds. So that's the moment of FB. Summing moments about B for, you know what, I messed up. There we go. Summing moments for force C about A, taking counterclockwise as positive. Well, we'll do the same thing. We need the vertical component of FC, so all we got to do, again, it's the cosine side. You see it's touching the angle, so cosine of 30 degrees times the moment arm. Well, let's see, 2.5 plus 0.75 would be what, 3.25 feet, right? Now FC is of course 50 pounds. And let's check our direction. Yeah, well, they're both counterclockwise, so both positive. And again, type this in. And you can see that not only is the magnitude of the force higher, but it has a larger moment arm, so we expect a larger number here. Of course, it is at a slightly larger angle. There's less of the force going into useful torque generation, but it's not a huge difference. And as a matter of fact, we get 140.73 foot-pounds or so. So we get about 150% of the torque from this hand that we get from this hand.